Alright, welcome back for a short fun-filled math video. In this little mini lecture I was going to do some examples of how to approach the order of operations through integers and fractions using the eyes of application problems. So remember, application is just a big scary word for saying word problem, i.e. we're looking at a sentence or a paragraph. And what you have to be able to do is take the information provided, create yourself your equation, solve your little equation, or simplify it down to state your answer. So applications for me is where math becomes fun because it's kind of like a puzzle. You have to use the clues given in the problem in order to figure out what to do. So let's look at some examples on how to kind of attack that using the order of operations. So first it says the square of 7/8 is subtracted from the square of 3/4. Find the difference. Okay, that's not so bad. So subtracted from this right here is what I like to consider a turnaround phrase. Turnaround phrase says whatever is going to come gets written up front, and whatever was said first gets written in the back. In other words, that means this piece of the puzzle here is going to be your start, and this piece of the puzzle here is going to be your end. The subtracted piece here is the operation used. So I'm going to do the square of 3/4. So this is 3/4, and I'm going to square it. My operation is subtracted, and then I've got the square of my 7/8. So this right here is the problem what to simplify. Okay, so this is what you need to simplify. So here, the first thing I have to do is I have to apply my square. So 3 squared is going to give me 9. 4 squared gives me 16. I'm still subtracting. 7 squared is going to give me 49. 8 squared is going to give me 64. So in this, I have to look at a greatest common denominator. So the first thing I would do is I would look to see if 16 and 64 are common with each other, and they are. In this case, my least common denominator is 64. And the way I turn 16 into 64 is multiply everything by 4. So this is actually going to give me 36 over 64 minus 49 over 64. And then I have to go ahead and reduce. So 36 minus my 49, this is going to give me a negative 13 over 64, and this is what I was looking for. Now the second one says find the quotient. Okay, and then it's if the sum of 12 and 28. So this right here, the sum of 12 and 28 is itself a term. So this is a term. And then this is going to be divided by the difference between. So the difference between 6 and negative 2 would be the other term. Now, because I'm dividing it by it, it means that this one is going to be your denominator. and this first term is going to be the numerator. So I have the sum of negative 12 plus 28 is divided by the difference between 6 and negative 2. Well, another way to write that would be to open a parenthesis, because in algebra the phrase the sum of means parentheses, and the difference between can mean parentheses. And so here we could open a parenthesis, and this would be negative 12 plus 28, and we're dividing this by 6 minus negative 2. So here, negative 12 plus 28 is going to give you 16, and I'm going to divide that by 6 minus a negative 2. So minus a negative is positive, so 6 plus 2 is 8. So again, we could go ahead and use the keep it. So keep the first, change the sign, flip your reciprocal. 16 over 8 is going to give me 2 as a result. Okay. Now the next one says find the average of negative 25, 30, negative 15, 6, negative 6, negative 26, and 18. So here again what we have to remember is that the average is going to be the sum of all the terms divided by the number of terms added. So to do that, says the first thing I have to do is I have the sum of all the terms. So this is negative 25 plus 30 plus a negative 15 plus a negative 6 plus negative 26 plus 18. And we are going to divide this whole thing by the number of terms. So we would simply add them up. We've got 1, 2, 3, 4, 5, 6. So this would be divided by 6. So here I have negative 25 plus 30 minus 15 minus 6 minus 26 plus 18. This is actually going to give me negative 24 as a result, and I'm going to divide this by 6 for my average. 24 over 6 is going to reduce down to 4, and because I have a single negative, it becomes a negative 4. Now the last one I wanted to look at has a lot of relation to a lot of students. In the problem it says that on an English exam 2 students scored 95, 6 students scored a 90, 3 students scored an 80, and 1 student scored a 50. What was the average score for the class? So here we have to look at what do we actually know. Well, first of all, we know 2 students scored 95. So I've got 95 and 95. I know that 6 students scored a 90. So that's 1, 2, 3, 4, 5, and 6 90s. 3 students scored an 80, so that's 1, 2, 3. and one student scored a 50. So if I want to know the average would tell me to sum up all the scores. So I'm going to sum all the scores and divide by the number of scores. So summing up all the scores says I'm going to do 95 plus 95 plus 90 plus 90 plus 90 plus 90 plus 90 plus 90 plus 80 plus 80 plus 80 plus 50. Whew! That's a mouthful. Another way that I could approach that would be this. I know 2 students scored a 95. Well, that's the same as 95 plus 95. I also know that 6 students scored a 90. I know that 3 students scored an 80, and I know 1 student scored a 50. Well, that leaves me with knowing that I had 12 students to begin with. So whether you just simply sum your individual digits or you get creative with your algebra, you'll get the same result. This is going to give you 1020 divided by your 12 students. And this is going to leave you with an average of 85. And that would be your average score. So those are some classic examples of what applications would look like, especially when dealing with the order of operations in terms of integers and fractions. Please be sure that if you have any questions, you let me know. Otherwise, remember, math is bananas. However, it's supposed to be fun. So please keep smiling, ask tons of questions, and enjoy what you're doing. And above all else, see you next time.